Hello, we are the Waiters Without Borders, team number 61, and we are presenting the Service Contact Enhancement System. My name is Daniel Kelly. I am in charge of putting together the tabletop device, as you will see in this video.
My name is Steven Rodofsky. I'm in charge of the wearable device.
My name is Nicholas Gunnels, and I'm in charge of the wireless communications.
My name is Victor Ho. I'm in charge of power and accessories.
The overall idea behind this product is to help increase communication between restaurant waitstaff and their customers, and this is the product sketch of our design. As you can see, on the left is the tabletop device in which the restaurant customers will input their requests, which are then sent to the wearable device, which the waitstaff wear, to be displayed on an OLED screen, allowing for waitstaff to more easily see what their customers need. Additionally, there is a push button used for sending audio signals between the two devices. This is the block diagram of our design. As you can see, the tabletop device is denoted by green blocks led by Dan, the yellow blocks denote the wearable device led by Steven, the blue blocks denote wireless communications led by Nicholas, and the red represents power, led by Victor. As you can see, there are several different components to each of the subsystems. Common between the tabletop device and the wearable device is a buck converter for power distribution, an ESP32 for wireless communications, and an I2S microphone and codec for encoding and decoding audio signals. The tabletop device is equipped with push buttons and indicator LEDs for processing requests, and the wearable device is outfitted with an OLED screen for displaying the received requests.
First button being pressed is water, ready for bill, ready to order, and you can see the LEDs lighting up. Beverage refill, napkins. Let's see what the screen says. It's like water, ready for bill, ready to order, beverage refill, and napkins. I'm going to go ahead and press the focus. I'm going to go ahead and press the reset button. All the requests are cleared. Let me press water again. Oops, I'll give it a minute to actually reset. There it is, there's water. Napkins. Beverage refill. Ready for bill. Let's just go ahead and see what's on there. So we got, oops, a little focus. Looks like water, napkins, beverage refill, and ready for bill. David, I'm going to send a napkins request.
Okay. Got it.
Testing, testing. 1, 2, 3. Testing, testing.
Testing, testing. 1, 2, 3. Testing, testing.
For the wearable device, here is what the overall system looks like. We got push buttons over here for a guest to input their request for whatever they'd like. Once they push any one of these buttons, one of these LEDs will light up to indicate that their request has been received. Both the inputs for the requests go to the ESP32. And using the ESP Now protocol, they'll be sent to the wearable device. And over here we have the I2S codec mic, that's up here, and the decoder for the speakers. So basically, when the button labeled push talk is pressed, the mic will start recording. After the button has been released, the audio will be encoded in I2S, and and once the button is pressed again, the audio is decoded using this this breakout board here from I2S back into regular audio, where it's played out of the speaker. If we had more time, we would ideally we'd like to be able to transmit this audio, but we were not able to get that working because sending audio via Wi-Fi proved we were very close to getting it to work, but we weren't quite able to. But ideally, I would be decoding audio recorded on the wearable device rather than my own device.
This is the wearable device local audio demonstration. Hello, testing. Could I get some ice cream at table 12, please? Hello, testing. Could I get some ice cream at table 12, please? Here we have the wearable device design. Comes in this little box. Ideally, there'd be a handle coming around here so that this server or waitstaff could wear it around their neck. But let's go ahead and take a look at what's inside. Actually, on top we have the OLED screen with a microphone hole and a speaker hole. And inside, because we couldn't get our PCB to work, we just inserted the breadboard with all the connected devices onto it. And so within this, first we have the speaker, 8 ohms, and that's pretty self-explanatory. But let's move on. And the speaker is connected to this little I2S codec. And this I2S codec is what converts the the audio signal from digital back to analog to be played through the speaker. Here we have the microphone, which is I2S compatible. So this microphone automatically takes that analog audio signal and converts it straight to digital to be passed through the ESP32 flash memory and then passed directly to this I2S codec. Anyways, also connected to the breadboard is the OLED screen, which gets its commands from the ESP32 that's in this little corner right here. And let's go ahead and lift this up and take some of this stuff out. So underneath all this, we have some padding to keep the components supported so that they can be touching these holes in the top of the housing unit. And if we remove the housing underneath all of this, we have the power supply unit, which is powered by a 9-volt battery delivering 3.3 volts to the breadboard and the ESP. And there's the wearable device subsystem.